Hello everyone. Today we continue with the numerical problems based on Raoult's law. So one more example is that heptane and octane. So hept means how much here? See, 7. Hept. AN indicates that double the number of carbons plus 2. Here double how much? 14. 14 plus 2, 16. C7H16 is what the formula of heptane. And octane. Oct indicates what? C8. Okay, and n double plus 2, 8 double what? 16, 16 plus 2, 18. So H18. So what your C8, H18 is octane, C7, H16 is what? Heptane. Okay, they form ideal solution. In the examples of ideal solutions formation we have discussed, heptane and octane form what? Ideal solution. Next, at 373 Kelvin, at 373 Kelvin temperature, the vapor pressures of the two liquids, the vapor pressures of heptane liquid and the liquid octane are 105.2 kilopascal and 46.8 kilopascal respectively. This is what now here, this is the partial pressure of what? Heptane. So what is this here? Vapor pressure of heptane. And what is this here? Second one, vapor pressure of octane. Vapor pressure of octane. So vapor pressures are mentioned here. Vapor pressures of what? Pure liquids they mentioned here. Vapor pressures of pure liquids they have mentioned. Okay. So one liquid acts as solvent, one liquid acts as solute here. So the two liquids are forming what? Ideal solution. Ideal solution is formed indicating what? When you mix heptane and octane, delta H mixing is 0, delta V mixing is 0. And the interactions between heptane and heptane molecules will be similar to the interactions between octane molecules will be similar to the interactions between heptane molecule and octane molecule. Then ideal solution is formed between heptane and octane. Now the pure liquid heptane, pure liquid octane. Okay, their vapor pressures are mentioned here. Now what they're asking here, see, what will be the vapor pressure in bar? Vapor pressure in bar, but they have given kilopascals, they are asking in bar. What will be the vapor pressure in bar of a mixture? Mixture means solution, ideal solution, of 25 grams of heptane and 35 grams of octane. Now weight of heptane is given, weight of heptane and weight of octane given here. From given weights we can calculate number of moles. Number of moles of heptane will be equal to given weight of heptane by gram molecular weight of heptane. Similarly, number of moles of octane is equal to given weight of octane divided by number of means gram molecular weight of octane. So given weight by gram molecular weight will give number of moles. So from given weights, what we can calculate here? From given weights, we can calculate the number of moles of heptane and number of moles of octane. When you know the number of moles of heptane and number of moles of octane, we can calculate mole fraction of heptane and also mole fraction of octane. That point we have to remember. So from given data, what we can calculate, we have to understand first. So in case of for some problems, heptane formula, octane formula will not be given. We have to recall the formula of heptane and formula of octane. And here this type of compounds are called hydrocarbons. In case of hydrocarbons, we have to remember. So METH, meth indicates what? C, one carbon, and ETH, it indicates two carbons. Okay, suppose ethane, say formula what? C2, H6, eth, C2, and AN means what? Double the number of carbons plus 2 will give number of hydrogens. So C2H6. And PROP, prop indicates what? C3. And but indicates what? C4. And pent, pent indicates what? C5. Pentane formula, pent C5, AN double plus 2 na, so C5 H12 will be the formula of pentane. Similarly hex formula C6. Hept, hept formula means number of carbons 7. And oct means C8. Non means C9. And DEC deck indicates what? C10, like this. Suppose you take octane, oct C8 AN means what? Double plus 2. So 8 double 16, 16 plus 2, 18. That's the formula of octane is what? CH, H18. So this way we have to recall the formula of what the given hydrocarbon, octane and heptane. These two will form what? Ideal solution. Now the solution understand here. The numerical means key solution is that. So heptane formula C7H16 and molecular mass, gram molecular weight of heptane how much? 100. Here 7 into 12 plus 16 into 1. 7 into 12 plus 16 into 1 will be equal to 100 here. Gram molecular weight of heptane how much? A. So they have taken heptane as what? Liquid A. Liquid A is heptane. Ma means what? Gram molecular weight of A. Liquid A 100 here. And octane formula C8H18. C8H18 is the formula of octane. So now here B, liquid B is taken as what? Octane. So octane is taken as liquid B, heptane is taken as liquid A. Now for octane, what is the gram molecular weight? 114. Here 8 into 12 plus 18 into 1 will be equal to 114 gram per mole. So gram molecular weight of liquid B, gram molecular weight of liquid A we know. Now check it here. Now number of moles of liquid A means what now here? Number of moles of heptane. Number of moles of heptane is taken here. So number of moles of heptane is equal to what? Given weight of heptane by gram molecular weight of heptane. So given weight how many grams? 25 grams. And gram molecular weight how much? 100 gram per mole. 100 gram per mole. Gram molecular weight. Therefore, how many moles heptane here? So 0.25 moles of heptane here. So 0.4, 0.25 moles of what? Heptane. So 0.25 heptane moles will be formed here. And now NB is what now? Number of moles of octane. Number of moles of octane. So octane, number of moles will be equal to the given weight of octane by gram molecular weight of octane. So gram molecular weight of octane how much? 114 gram per mole. 114 gram per mole is the gram molecular weight. Given weight of octane how much here? 35. So given weight by gram molecular weight will give 0.3 moles of octane. So 0.3 moles octane, 0.25 moles of heptane. Now total moles will be 0.25 plus 0.3, total number of moles. Now see here, XA is what now here? Mole fraction of So mole fraction of what? Heptane. Mole fraction of heptane. So mole fraction of heptane is equal to number of moles of heptane divided by total number of moles. Number of moles of heptane how much? 0.25. So 0.25 divided by total number of moles of the mixture. This is mole fraction of heptane. That is mole fraction of liquid A. How much it is? 0.45. If you know mole fraction of liquid A, mole fraction of liquid B will be equal to what? XA plus XB must be equal to what? 1. XA plus XB is equal to what? 1. So like that here, mole fraction of A plus mole fraction of B is equal to 1. Therefore, XA if it is 0.45, then XB must be 1 minus 0.45. That is what now here 0.15, 0.55. So 0.55 is what? Mole fraction of octane. So mole fraction of liquid A, mole fraction of liquid B we understood here. Now P is what here? The vapor pressure, total vapor pressure of mixture. Mixture of how many liquids here? 2 liquids. Mixture means what? Ideal solution here. The ideal solution, that is mixture of what? Heptane and octane. The total vapor pressure P total is equal to the vapor pressure of liquid A plus the vapor pressure of liquid B. The partial pressure of liquid A plus partial pressure of liquid B is equal to total pressure of the mixture of 2 liquids. So here, now what is the pure liquid A vapor pressure given? 105.2 kilopascal they give. What is PA not given? 105.2 kilopascal. PA not means what? The vapor pressure of pure liquid A. The vapor pressure of pure liquid A is given 105.2 kilopascal into mole fraction of A. How much we got? 0.45 we got. 0.45 plus into 105.2. It is what now? Vapor pressure of liquid A. Partial pressure of liquid A plus partial pressure of liquid B. is given by what? PB naught XB. PB naught XB. So this PB naught XB. PB naught how much is given? 46.8 kilopascal given. 46.8 kilopascal is PB naught XB into what is mole fraction of X here, B here? Mole fraction of XB is equal to 0.55. 0.55 into 46.8. So this way we get what is this here? Partial pressure of liquid A plus partial pressure of liquid B is equal to total vapor pressure. Total vapor pressure of mixture here. So it is in kilopascal. Okay. Next, if they ask you to calculate in what here bar, how to calculate now here? Generally we know that 1 bar is equal to, just 1 bar is equal to what? 10 power 5. 1 bar is equal to 10 power 5 Pascal. Okay, so 10 power 5 Pascal equals to 1 bar, isn't it? So now we have to convert these Pascals into what? This one. Now here how many kilopascal? 73. How many Pascal? 73.08 into here, kilo means how much? 10 power 3 Pascal. So here 73.08 into 10 power 3 kilo, how much? 1000. So 10 power 3 Pascal will be equal to how many bar? Will be equal to how many bar? Here 10 power 5 Pascal equals to 1 bar. Then these many Pascal equals to how many bar? We can convert into bars. So we can say total pressure in bars. Conversion factor understood here. 10 power 5 Pascal equals to 1 bar. Therefore, 73 into 10 power 3 Pascal will be equal to how many bar? We can calculate. Next. So another example is that here mole fraction of the component A. Mole fraction of component A in vapor phase. In which phase? They're not liquid phase here. In vapor phase is X1. Okay, X1 is what now here? Vapor pressure of what here? Liquid A or component A in which phase here? Vapor phase is given X1. X1, isn't it? So just wait, just a moment. Yeah. So and what is the mole fraction of component A in liquid mixture is X2. What they have given here? Mole fraction of the component A in vapor phase is X1 in vapor phase, and the mole fraction of component A in liquid mixture is X2 here. X2 is in liquid phase, X1 is in vapor phase. Okay, then PA naught is what here? Vapor pressure of pure liquid A. PA naught is what? Vapor pressure of pure liquid A. PP naught is what? Vapor pressure of pure liquid B. Pure liquid B. The total vapor pressure of liquid mixture is what? The total vapor pressure of liquid mixture according to Raoult's law we have to calculate. Now check it here. So options given here. Now hint is what now here? Partial pressure of A is equal to the vapor pressure in pure liquid state, into mole fraction in liquid. So it is what X2 is what now here? Mole fraction liquid now here. Mole fraction of A in liquid phase is what X2 here. That's why PA naught is what? Vapor pressure of pure liquid A into the mole fraction liquid. Mole fraction in liquid is equal to PA. PA means vapor pressure of A. What is there? Partial vapor pressure of A, liquid A. Okay. Next, vapor pressure of A is what now here? PA. Vapor pressure of A is what? PA. Then mole fraction of A in vapor phase. Mole fraction of A in vapor pressure. Vapor phase is equal what now here? PA, partial pressure by total pressure. Generally, partial pressure is equal what? Mole fraction into total pressure now. So what is the partial pressure of A? Partial pressure of A is given as PA here. Partial pressure is equal what generally? Mole fraction in liquid vapor phase. Mole fraction in vapor phase, how much is given here? X1. Mole fraction in vapor phase, how much? X1 into mole fraction into total pressure, P total. So total pressure into mole fraction is equal to partial pressure of A. That is what now here it is called Dalton's law. Dalton's law. According to Dalton's law, what is the partial pressure now? Partial pressure of A is equal to mole fraction of A in vapor phase. Mole fraction of A in vapor phase mentioned what in the problem X1 into total pressure of the gaseous mixture. Total pressure of the mixture of two vapors, P total. That's why from this X1 is equal to what now? X1 is what? X1 is equal to PA by P total. This PA by P total will be equal to X1 here. So X1 is equal to PA by what? P total. P total. Now PA means what again? PA is equal to PA not X2 now here. PA not X2. So in place of PA, what we have substituted here? PA not X2. PA not X2 by P total. Isn't it? So from this P is equal to, now if you take P this side, X1 will come this side. So P is equal to PA not X2 by X1. So this is what they ask here. This P total they have asked here. The total vapor pressure of liquid mixture is what? P total is what they ask. Okay. Take the screenshot of this one. Take the screenshot. Yeah. So next example is that here what is given? Vapor pressure of pure liquid A, PA naught is given 100 mm of mercury. 100 mm of mercury is what here? Vapor pressure of pure liquid A, PA naught is given. And vapor pressure of pure liquid B, PB naught is given 150 mm of mercury. 150 millimeter of mercury is what? Vapor pressure of pure liquid B, PA naught and PB naught given here. 2 moles of liquid A and 3 moles of liquid B. Here number of moles of A, how much? 2. Number of moles of B, 3. So 2 moles of liquid A and 3 moles of liquid B are mixed to form an ideal solution. So which solution is formed here? Ideal solution is formed. Ideal solution is formed indicating which law is obeyed here. This ideal solution obeys which law? It obeys Raoult's law. Okay. Now Raoult's law formula we have to recall. The vapor pressure of solution will be what? The vapor pressure of total solution is what? They ask here. So now listen carefully. Here XA is what? Mole fraction of A. What is A here? XA here? Mole fraction of A. So mole fraction of A is equal to number of moles of A by total number of moles. Total number of moles how much here? 2 plus 3. 2 moles of A plus 3 moles of B will be totally 5 moles. So number of moles of A divided by total number of moles, 2 by 5. Similarly, XB is what? Mole fraction of B. Mole fraction of liquid B is equal to number of moles of liquid B divided by total number of moles. So 3 by 5 is what? Mole fraction of XB. Mole fraction of liquid B. XA is what? 2 by 5. Now total pressure. What they asked here? Total vapor pressure of solution. So P is what now here? Total vapor pressure of solution. Total vapor pressure of solution P total is equal to partial pressure of A plus partial pressure of B. Partial vapor pressure of liquid A plus partial vapor pressure of liquid B. So here PA plus BB. PA value plus BB value. So this is what now here PB. And what is this here? PA. So PA plus PB is equal to P total. So P of solution. P of solution is equal to what more? Partial pressure of A plus partial pressure of B. That means vapor pressure of liquid A plus vapor pressure of liquid B is equal to P total. So here now again PA is what now? Partial pressure of A or vapor pressure of A is equal to PA naught into XA. PA naught into XA. PA naught is what here? PA naught is what? Vapor pressure of pure liquid A into mole fraction of A. XA already we have taken here, XA. So PA naught is given. PA naught is given what? 100 millimeter of mercury given. And PB naught how much is given? 150 millimeter of mercury given. And XB value already we have got 3 by 5 XB. So we know all the values. By substituting the values we get what? P total. So P total of solution is equal to 130 mm of mercury. 130 millimeter of mercury is what? Total vapor pressure of solution. So it's about what now here? One of the important problems of based on Raoult's law. So another important problem is that another important model is that the vapor pressure of a certain pure liquid A at 298 Kelvin is given. Okay. So what is given here? Pure liquid A means what is this here? PA naught. What is PA naught? PA naught means what? Pure liquid A vapor pressure is given millibars. Okay. Next, when a solution of B is prepared in A, when a solution of B is prepared in A, means B is added to what? A. So B liquid is added to A. to give what? Some solution. Some solution is found by dissolving B in A at the same temperature. At the same temperature, we have mixed B with A to get some solution. The vapor pressure is found to be 32 millibar. So it is what now here? P of solution. P of solution, vapor pressure, total vapor pressure of solution we have got how much here? 32 millibar. Okay. Now the mole fraction of A in the solution is what? The mole fraction of A means what? XA. XA is equal to what? XA value they asked here. Okay. Now check it here. What is given here? At 298 Kelvin, the vapor pressure of pure liquid A is given 40 millibar. PA naught is given here. Okay. When a solution of B is prepared, in A, okay, at the same temperature, the vapor pressure is found to be 32 millibar. Means what? 32 millibar is what now here? P of total solution. The mole fraction of A in the solution is what they ask. Now P is equal to what now here? PA naught into XA. P is equal to PA naught into XA. Okay, ma. Then and 32 is equal total pressure. Now why we have taken here? P total is equal to PA plus PB. Okay, PA plus PB. Here PA is what now here? PA naught into XA, right? PA naught into XA. But here it is non-volatile solid take because PB not mentioned here. PB naught is not mentioned. So this B should be taken as what? Non-volatile liquid. Non-volatile liquid. B should be taken as what here? Non-volatile liquid here. Non-volatile solute. Non-volatile solute to take. So non-volatile solute B is taken. That's why PB not given. PB naught and XB. So here not given here. When PB naught is not given, we cannot get what? PB. That's why the P total, P of solution is equal to PA only here. P of solution, total vapor pressure of solution must be equal to only PA plus PB 0. The total PB is what? 0 here. That's why PA only will be taken. That's why P total is equal to PA. PA means what? PA naught into XA. PA means what here? Vapor pressure of pure liquid A into XA. So here P total 32 is equal to here 40 PA naught value into XA. So XA value they ask here. So XA is equal to what now here? 32 by 40. 32 by 40. That is what now? 0.8. So mole fraction of A is what? 0.8. When you take mole fraction of A as 0.8, mole fraction of B will be what? XB will be 1 minus 0.8. So that way we have to understand. Here PB not given. That means we have to take what? PB value should be taken 0. Then total vapor pressure of solution is equal to PA only we take. That's why we have taken what now here? PA naught into XA only we have taken. Okay, it is another example problem. Now one more problem is that 100 ml of liquid A and 25 ml of liquid B. 100 ml of liquid A and 25 ml of liquid B are mixed to form a solution of volume 125 ml. Okay. Initially, how much here? Solute plus solvent. How much here? It is solvent. Volume of solvent. Volume of solvent. Sorry. Volume of solvent and volume of solute. Just a moment. So volume of solvent. Yeah. So volume of solvent is given what now? 100 ml and the volume of solution or solute. Volume of solute is given what? Only 25 ml. Now these two mixed to get what now? 125 ml. Now any difference is there? Delta V mixing. Delta V mixing is equal to, now what is the formula here? V of solution minus here V of solvent plus V of solute. Now V of solution, how much volume of solution formed? 125 ml minus here VA how much taken? 100 ml plus VB how much? 25 ml. That's why the delta V mixing is equal to 0. So whenever delta V mixing is 0, that must be what now here? Ideal solution. That's why it is ideal solution. Why it is ideal solution? Delta V mixing is equal to 0. Hence the solution is ideal. And whenever delta V mixing is 0, and also what we have to take? Delta H mixing. Delta H mixing also will be 0. Delta H mixing meaning what here? Enthalpy change of mixing also will be 0. So enthalpy mixing is 0 and delta V mixing is 0. Whenever we get what? Ideal solution. So one more problem is that the vapor pressure of pure benzene at 88 degrees Celsius is given here. It is what now here? Pure liquid benzene vapor pressure, pure liquid. And that of toluene. Toluene at the same temperature is mentioned what? 379.5 mm. 379.5 mm is what now here? The vapor pressure of toluene, and vapor pressure of pure benzene is given. So liquid A, liquid B we have taken here. Liquid A and liquid B. Now next one. Calculate the composition of benzene toluene mixture boiling at 88 degrees Celsius. At 88 degrees Celsius, with this mixture is boiling. Then what will be the composition of vapors of benzene and vapors of toluene? They ask. Okay, so now you see the hint is that the P total of solution, okay, total vapor pressure of solution. Total vapor pressure of solution is equal to what now? The partial vapor pressure of benzene plus partial vapor pressure of toluene. Okay, so the vapor pressure of benzene plus vapor pressure of toluene is equal to what? Total pressure of mixture solution. Now here, what is partial pressure of benzene formula? Okay, pure liquid benzene's vapor pressure into mole fraction of benzene plus pure liquid toluene vapor pressure into mole fraction of toluene. Okay, now here what is given? 760. 760 is what here? 760 mm is what? 180 mm. Whenever boiling is going on, at boiling point, when this mixture is boiling at 88 degrees Celsius now, that's why the total pressure, P total should be taken as 1 atm. 1 atm means what? Atmospheric pressure. Atmospheric pressure, how much more? 760 mm. Suppose when liquid water is boiling, at boiling point 100 degrees Celsius for water, what will be its vapor pressure? It will be equal to 1 atm. So the vapor pressure of any liquid will be equal to 1 atm or 760 mm at its boiling point. That's why here, when mixture is boiling, at this boiling point, what will be the vapor pressure? Total vapor pressure 1 atm. 1 atm is equal to how many mm? 760 mm. That's the total pressure is taken what? 760 mm. 760 mm. That equals to what is the pure benzene vapor pressure given? 957 into mole fraction of benzene we do not know. Plus again, what is pure toluene's vapor pressure? 379.5 into 1 minus mole fraction of benzene. So mole fraction of benzene plus mole fraction of toluene will be equal to what? 1. Whenever mole fraction of benzene is taken x benzene, then x toluene is equal to what? 1 minus x benzene. 1 minus x benzene we take. Now x benzene we have to, in terms of x benzene we have to get. X benzene is equal to 0.66. Whenever x benzene, mole fraction of benzene is 0.66, x toluene, mole fraction of toluene is equal to what? 1 minus 0.66, that is 0.34. 0.34. So mole fraction of benzene is what? 0.66. Mole fraction of toluene is 0.34. So these are some of the important problems based on what? Raoult's law. Okay. The remaining problems also prepare from material. Okay. Bye. Good day.